Hey, this is Mr. Beckstrom, and today I'm going to take a look at an example problem from section 5.6. This is on logarithmic and exponential equations, and this one is a doozy. So it says solve the following exponential equation, express irrational solutions in exact form and as a decimal rounded to 3 decimal places. So here's the problem we have here. This is 7 raised to the 2x plus 7 raised to the x minus 6 is equal to 0. And it's probably not immediately clear what we need to do with this, but we should see, hopefully, that it's in some type of, it kind of looks like a polynomial, right? So we have this kind of a squared term, just an x term, and a constant there. So we can make use of that to rewrite this. And the way I'm going to rewrite this is I need these two kind of bases to be the same. So I need both of those to be 7x. So that's what we're going to use, or 7 raised to the x as our base. So if I raise the first one, 7 to the x, then all that's left over is the 2. So I'm going to have the 2 out there. And remember, when you take an exponent to an exponent, you multiply those two exponents together. So this is, in fact, the same as this first term here, plus, and this is going to be 7x, or raised to the x, and this is going to be raised to the first power, and then we have minus 6 here. So how do we make use of this? Well, I'm going to do some what's called u substitution, and that's where I'm going to let this 7 raised to the x equal some variable. In this case, I'm going to let u equal 7 raised to the x, and if I do that, then this problem here becomes u squared plus u minus 6 is equal to 0. And this is a much easier problem to solve. Now we just have kind of a simple quadratic to factor. And just remember, whenever we make a substitution, we have to do the reverse substitution at the end. So this factors pretty nicely for us into u plus 3 times u minus 2 is equal to 0. And that means that we're going to have u is equal to 2 and negative 3. We have two solutions for the u variable. Now we have to do the reverse substitution, which means that we have two equations here now. We replace u with 7 to the x, so 7 to the x is equal to 2. And we have 7 to the x is equal to negative 3. Now, remember, 7 raised to a variable is always going to be a positive number. Why? Well, because if I have a positive x here, that's just going to be a positive number raised to a positive number, which gives me a positive number. If this is a negative value here, we just put it 1 over 7 raised to a positive value, which gives us a positive value. And if this is 0, any non-zero raised to the 0 power is equal to 1. So there's no possible way for any real value of x that I could possibly get a negative. Therefore, I don't even have to look at this equation here. The only one that I have to work is here. So when I have a variable in my exponent, a very common remedy that we're going to use is we're going to just take the natural log or the regular log, either one of both sides. So the natural log of 7 raised to the x is equal to the natural log of 2. I just took the natural log of both sides. Now remember, using rules of exponents in logarithmic functions, I can move the exponent out to the front. So this becomes x times the natural log of 7 is equal to the natural log of 2. And finally, I'm going to divide both sides by the natural log of 7, and I get x is equal to the natural log of 2, all divided by the natural log of 7. So that is my answer in the exact form. And then to get a 3 decimal place approximation, what I'm going to do is, oops, just put it in my calculator. So natural log of 2 divided by the natural log of 7. And I'm going to get 0.356. So that would be my 3 decimal place approximation. And that's it. So I guess it wasn't too bad, but it is kind of messy, and we do have to kind of see that we can use a u substitution in the beginning to make this into a quadratic, which we can then factor and then do the reverse u substitution in there. All right. Well, if you have any questions, please let me know, and I hope you have a great rest of your week. Thanks.